Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is a pure Mathematics 3 for February-March 2022, and the code is 9709/32. So let's move on to question number 1. Okay, so for question number 1, solve the inequality modulus of 2x plus 3 greater than 3 times modulus of x plus 2. So I will solve this using the definition of the modulus function, which is square root of 2x plus 3 squared is greater than 3 square root of x plus 2 squared. That's the definition of the modulus function. So to solve this, we will try to we will square both sides. Okay, so the square and square root can be cancelled off, and then this square bring into both. Right? So then you will be getting 2x plus 3 squared greater than 3 squared is 9, then x plus 2 squared. Then now do the expansion using quadratic formula. A plus b squared is a squared plus 2ab plus b squared. Then you will be getting 4x squared plus 12x plus 9 greater than 9 times x squared plus 4x plus 4. Okay, then here is greater than 9x squared plus 36x plus 36. So now I will move all the terms to the right hand side to get positive. So here is going to be 0 greater than, so 9x squared minus 4x squared is 5x squared. Okay, then now 36x minus 12x, you'll be getting plus 24x. Then lastly, 36 minus 9, it will be plus 27. Okay, so now here I will rearrange. It will be 5x squared plus 24x plus 27 is less than 0. So now this quadratic can be factorized into two linear factors, which are 5x plus 9 and x plus 3 less than 0. Now to get this inequality, right, to solve this inequality, I will refer back to this quadratic function. Okay, since the coefficient for x squared is positive 5, that means I will be getting a minimum point if I sketch the graph. And the horizontal axis is the x. Now, by looking at these two values, the first one, the x will be negative 9 over 5. And the second one is negative 3. So, negative 3 obviously is less than negative 9 over 5. That means it will be on the left-hand side of the graph. Now, the whole graph is the whole final answer will be based on the last part, which is less than 0. So less than 0 means the region will be below the x-axis. Therefore, you will be getting the answer between negative 3 and negative 9 over 5. So this is how I solve this question. Now question number 2. Sketch on a sketch of Argand diagram, shade the region whose points represent complex numbers z satisfying the inequality and the inequalities modulus z plus 2 minus 3i less equals to 2. So this means modulus of z minus negative 2 plus 3i less equals to 2. Then this is a circle. Okay, this is a circle equation with center at minus 2, 3, and then the radius at 2. Or the radius unit is 2. Okay, then now argument z less equals to 3 over 4. That means here your reference point is at 0 plus 0i, which means it's at the origin. Okay, so now to sketch the circle with center minus 2, 3. Let's say for example, okay, now for this I will draw the circle first, then I will adjust my labeling for the axis. So I know that here is negative 2, 3. This is negative 2, 3. Then radius is 2 means that here is 2. Okay, then here is going to be 0. But then since this is minus 3, here is going to be 3. Right? So now I will add on the axis. Here is a real axis. This is 2. Okay, so here is 2 units because the radius is 2. So 3 minus 2 is 1. Here is 1. That means here is 1, probably here is 2. Okay, or I will not label this. Alright, so then here is going to be 1. Here is 0. Then here is 2, negative 2. Okay, then here is 0. Then this is going to be 5, because the radius is 5. Then here is going to be negative 4, because of the radius is 2. Okay, so I have sketched the circle with radius 2. Now another one is 0, 0. This is a point. 3 over 4. So 3 over 4, when you consider the tangent, it will be 45 degrees, or I mean it will be 135 degrees. Okay, so 135 degrees means where x is 1, y is 1. Let's say here is 2. Or I will say that if this is minus 2 minus 4, the middle is minus 3. So here is minus 3. The line passes through these 2 points. So just use a ruler to join the straight lines. Right? So let's say this is a straight line. Cannot be more than 0. It will be just up to 0. Okay, my graph is not very accurate. That's why you need to draw using ruler. Okay, so now here is going to be 3 over 4 pi. And since it's mentioned that the argument is less than or equal to 3 over 4 pi, that means your region is going to be here. Alright, it is less than. So that's the solution of this question. This is the real part. My labeling is wrong. This is imaginary. Okay. So that's all for the question 2. Right. Now question 3. The variables x and y satisfy the equation where n and c are constants. The graph of ln y against ln x is a straight line passing through these 2 points, as shown in the diagram. Now find the value of n and find the c correct to 2 decimal places. So I will start with this equation first and take ln both sides, so that ln y against ln x. So I will write x degree n y squared equals to c. I take ln both sides. So just one ln is allowed. And then now here I will use the formula. Ln AB is ln A plus ln B. Now I will split it into 2 ln. It will be ln x degree n plus ln y squared equals to ln C. And then we have another formula, which is ln A to the power B is B ln A. So now the power n and power 2 can be brought down. Then I will get n ln x plus 2 ln y equals to ln C. Okay, and now it's mentioned that ln y against ln x. So your new y-axis is ln y, new x-axis is ln x. So now here, 2 ln y is negative n ln x plus ln c. Hence, my ln y is going to be negative n over 2 ln x plus ln c over 2. Okay, so this is similar to y. This is my m, this is x, then plus c. Okay, so now to get the n and c, the n over 2 is the gradient. Okay, so now I will refer to the 2 points. So 0.31, 1.21. This is my ln x, this is ln y, and another point 1.06, 0.91. This is my ln x, this is my ln y. Now to get n and c means that you need to solve the simultaneous equations. So I will substitute into this equation right now. Alright, so for the first point, 1.21 equals to negative n over 2. Ln x is 0.31. Then plus ln c over 2. This is my first equation. And then for the second point, I will get 0.91 equals to negative n over 2 times 1.06 plus ln c over 2. Now, obviously the last term is the same, then I will just minus. So first equation minus second equation. The left hand side will be 0.3. Then the right hand side, right, when you calculate all and minus, you will get 3 over 8n. Therefore, from here, my n is going to be 0.3 times 8 over 3. So it will be 0.8. I found the n. Okay, and here correct to 2 decimal places, so add on 1 more 0. Now to get the c, I will substitute into the first equation. So now I will get 1.21 equals to negative 0.80 divided by 2 times 0.31 plus ln c over 2. So from here, my ln c over 2, you will get this term move to the left side, okay, becomes plus, and you will be getting 1.334. Then now, my ln c is 2 times 1.334, which is 2.668. To get the c, we have a formula. To eliminate the ln, I will just take e both sides, okay, because e ln a is a. So now I will take e both sides. So e ln c is e 2.668. Then e ln c is going to be my c. So my c is e 2.668. And now just count this value correct to 2 decimal places. That will be 14.41. Therefore, my n is 0.80 and c equals to 14.41. So that's the solution of this question. Question number 4. The parametric equations of a curve are x and y. Show dy dx. So x equals to 1 minus cos theta. Now, here we need to get dx over d theta. So when differentiate 1, you get 0. Differentiate negative cos theta is sine theta. Then the y is cos theta minus 1 over 4 cos 2 theta. When you differentiate cos theta, the answer is minus sine theta. So I copy the negative 1 over 4. Differential cos is negative sine. Rewrite the 2 theta. Differentiate 2 theta is going to be 2. Then from here, I will get negative sine theta. So now, the 2 and 1 over 4 becomes half. Then the plus, minus, and minus is a plus. So I will get plus half sine 2 theta. Then, now my dy over dx is going to be dy over d theta. Sometimes you can write times d theta over dx, or you can just write times dy by dx over d theta. It's the same, okay? So for your information, d theta over dx is same as 1 over dx over d theta. So now here, I will get minus sine theta plus half sine 2 theta, you times 1 over sine theta. And now you need to get this. So now, to get 1 over sine theta here, right, but because we have the cos sine 2 theta here, I need to use the double angle formula, which is sine 2a is 2 sine a cos a. So now your a is theta. That means now I will get minus sine theta plus half of 2 sine theta cos theta. Then you times 1 over sine theta means that over sine theta. Okay, so from here I can factorize the sine theta. Then you get minus 1 plus. Now the 2.5 cancel off. Therefore, you will be getting cos theta over, this is my sine theta. Okay, let me write properly. Then now obviously the sine theta can be cancelled off. Then I will be getting negative 1 plus cos theta. Okay, I will be getting cos theta minus 1. But then when you look at the answer here, we need sine squared. Alright, so to get sine squared sine square half theta, if you notice that, sine square half theta. So for this case, I have to refer to the double angle formula, cos 2a. So cos 2a, we have three forms. Now we have to choose the form which has sine squared, which is 1 minus 2 sine squared a. So now I need cos theta minus 1. So cos 2a, that means 2a is theta. So now your a is theta over 2. Okay, now here, if I move the 1 to the left hand side, I will be getting cos 2a minus 1, which is negative 2 sine squared a. Then now I replace my 2a by theta. That means this is going to be negative 2 sine squared. My a is half theta. Okay, so it is exactly the same as the given answer. Alright, so this is the working for question number 4. Okay, question number 5. The angles alpha and beta lie between 0 and 180 degrees, and such that tangent alpha plus beta is 2, tangent alpha is 3, tangent beta. Find the possible values of alpha and beta. Now, I will start with this expression. So tangent alpha plus beta equals to 2. Then now we have to solve using tangent a plus b equals to tangent a plus tangent b over 1 minus tangent a tangent b. This is the formula. Okay, then now I will be getting tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta equals to 2. And now it's mentioned that tangent alpha is 3 tangent beta. So tangent alpha is 3 tangent beta. I'm going to replace this. So it becomes 3 tangent beta plus tangent beta over 1 minus tangent alpha is 3 tangent beta. So this one will replace. So 3 tangent beta times tangent beta. That equals to 2. So now to solve the alpha and beta, I will just move the denominator to the right side. Then here I will be getting 4 tangent beta for the numerator. Then after I move, I will get 2 times 1 minus tangent beta times tangent beta is tangent squared beta. So 3 tangent squared beta. Okay, and now here I will do expansion. It will be 2 minus 6 tangent squared beta. Then for the left hand side, it will be 4 tangent beta. So I will move all the terms to the left hand side in order to get positive tangent squared beta. So I will get 6 tangent squared beta plus 4 tangent beta minus 2 equals to 0. Now the whole equation can be divided by 2. So it becomes 3 tangent squared beta plus 2 tangent beta minus 1 equals to 0. And now this quadratic equation in terms of tangent beta, it can be factorized into 2 linear factors. So I'll get 3 tangent beta minus 1 multiplied with tangent beta plus 1 equals to 0. Which means now multiplication of 2 terms equals to 0 means one of the terms must be 0. Okay, so from the first expression, I will be getting tangent beta is 1 over 3. And the second expression, tangent beta is minus 1. Okay, now let's look at the interval. The alpha and beta lies between 0 and 180 degrees. So, means that now beta lies between 0 and 180 degrees. So, it means the first two quadrants. Now, your tangent beta is positive. It will be in the first quadrant. So, now my beta, when you just take inverse tangent 1 over 3, it will be 18.4 degrees. So, this is our first angle. Okay, and for the next one, since the tangent is negative, that means it's in the second quadrant. So when you take the inverse of minus inverse tangent -1, you will be getting 45 degrees. Sorry, inverse tangent 1, it will be 45 degrees. The minus is just to show the position of the angle. So now here is going to be 180 minus 45. So beta is 180 minus 45 degrees. Therefore, it will be 135 degrees. So now here we get 2 beta. Alright, and don't forget that just now you were given tangent alpha is 3 tangent beta. So now tangent alpha is 3 tangent beta. Okay, so when tangent beta is 1 over 3, that means now tangent alpha is 3 times 1 over 3, which is 1. So when tangent alpha is 1, okay, so when you refer to the quadrant, inverse tangent 1 is 45 degrees. That means I will get alpha is 45 degrees. Alright, and then when tangent beta equals to minus 1, then my tangent alpha is 3 times tangent beta, which means minus 3. So when minus 3, right, it is in second quadrant, and when you take the inverse of inverse tangent 3, you will be getting 71.6 degrees. But then our angle is the major angle. So now my alpha is 180 degrees minus 71.6 degrees, which is 108.4 degrees. So now my conclusion, when alpha is 45 degrees, my tangent beta is 1 over 3, which is 18.4 degrees. Okay, and another set of the answer will be when alpha is 108.4 degrees, my beta is going to be 135 degrees. Okay, so that's the solution of this question. Now question number 6. Find the complex numbers W which satisfy the equation. Now this is conjugate, alright? Conjugate of the W. N are such that real W is the X, right? Is less equals to 0. Given the answers in the form of X plus YI or IY, where X and Y are real number. So firstly, I will let my W be X plus IY. That means the conjugate is X minus IY. So now W squared plus 2I conjugate equals to 1. That means X plus IY squared plus 2I times X minus IY equals to 1. So here I have to do expansion. Quadratic expansion, right here, A plus B squared, it will be A squared plus 2AB plus B squared. This is the quadratic expansion that I'm going to refer to. Here will be X squared plus 2XYI plus I squared Y squared. Then here you do expansion. 2xi minus 2yi squared equals to 1. Now, for your information, I squared is minus 1. So that means this is minus 1. This is minus 1. Okay? So, I will write x squared plus 2xyi minus y squared plus 2xi minus, this minus and minus becomes plus 2y equals to 1. The 1 you can either move to the left side or just stays on the right side, up to you. So now I will group the real and imaginary parts. So the real parts will be x squared minus y squared plus 2y. That's my real part. And my imaginary parts will be 2xyi plus 2xi. Then now for the right hand side, instead of 1, I will write 1 plus 0i. Okay, then now I will compare. So x squared minus y squared plus 2y is 1 on the right hand side. Then for the imaginary part, I will get 2xy plus 2x equals to 0. So now for the second equation here, I let this be the first equation. For the second equation, I will factorize the 2x. Okay, which means now from the second equation, multiplication of two terms is 0 means that either the first term is 0 or the second term is 0. So when first term equals to 0, my x is exactly 0. The second term equals to 0, my y is minus 1. Okay, so now I will substitute both values into the first equation. So when x equals to 0, for the first equation, 0 minus y squared plus 2y equals to 1. Then from here, I will move all the terms to the right side first. Y squared minus 2y plus 1 equals to 0. Now this quadratic equation can be factorized into y minus 1 squared equals to 0. Therefore, I'm getting y is 1. Okay, now for the second result, so from 1, okay, the y equals to minus 1. So now, when you substitute into the first equation, I will get x squared minus 1 squared, refer to this first equation, then plus 2y equals to 1. Okay, so the y is minus 1, so it means that last term I have to replace. Last term on the left side, I have to replace the y by minus 1. Then from here, I will get x squared. Minus 1 squared is 1. Then there's a minus outside, so minus 1. Then here minus 2 equals to 1. That means now, my x squared, the left hand side minus 1 minus 2 will be minus 3. Move the minus 3 to right side becomes plus 3. Then you'll be getting 4. Then now I'm getting x is plus minus 2. Okay, now let's check the condition just now. Given the real part, okay, real part is basically the x. Real parts of the w is x. X must be less than 0, less than equals to 0. So now, this one no problem because it's exactly 0. But then here, x equals to plus minus 2. Right? Means that we cannot accept the positive 2. So given real w less equals to 0. Right? Here. That means the x must be negative 2. Okay? Therefore, your w is, we know that I have defined the w as x plus iy. So now, for the first pair of answer, x is 0, y is minus 1. So it will be 0 minus 1i. Okay, and then for the second one, the x is minus 2, and then the y is minus 1. Therefore, I will say w is minus I and minus 2 minus I. So that's the solution of this question 6. Now for question 7, by sketching a suitable pair of graphs, show that the equation has exactly one root in the interval x from 0 to pi. So now suitable pair of graphs means that you have to sketch both graphs, right? Two graphs. So I will let y1 be 4 minus x squared, and then y2 be the second half x. Now for your information, the second is basically 1 over cos half x. So now I refer to the cos graph first. Cos graph is, this is a cos graph. This is cos 1x. Okay, now we need to sketch cos half x. Half x means we will just take this. This is half x. Okay, but when you sketch half x, then it's already, when you do labeling, it's already 2 pi here. This is cos half x. Then here is pi. Alright, and now we are sketching from 0 to pi, which means now we are just taking this part. Okay? But then now I need to sketch 1 over cos. So when 1 over cos is basically, here is pi, here is 1, because here is 1, 1. This is for cos. Right? So now, when I sketch, 1 over 1 is still 1. But then when you come to this point, it is 0. So 1 over 0 is error. That means it will be infinity. Because from 1 drop, right, the graph is here, drop. So 1 over drop, it will be increasing, right? So here will be just this part. So this is going to be my second half x. Alright, so now I will sketch both graphs on the same diagram. here is my pi. I draw the dotted line to show that it is an asymptote. The graph never touch. Okay, make sure it is a straight line. Then now here is 1. Okay, for your information, the pi is 3.14. So let's say here is 1, here is 2. Okay, here is 2, here is 1. So here is 1. So my graph will be like this. Now, this is my y equals to second half x. Now for my y1, this is a quadratic equation which has a maximum point. So I know that my y1 is 4 minus x squared, which means it will be 2 squared minus x squared. It's the same as 2 minus x times 2 plus x. So when y equals to 0, okay, y equals to 0, that means 0 equals to 2 minus x times 2 plus x. Then my x is going to be 2 and minus 2. So 2 and minus 2 supposedly like this. Right, supposedly like this, because it has a maximum point. When x0, your y is 4. But then, since we sketch from 0 to pi, that means we don't bother this part. I will just draw this part. Okay, so when x is 2, y is 0. Then when y is 0, when x is 0, the y is 4. So let's say here is 2, 2, 3, 4. Then now I'm getting this graph. It is a quadratic curve. Okay, let's say here is 2. Right? So now, obviously, from here we have one intersection point. So this is y equals to 4 minus x squared. So now, you just write, there is only one intersection point between two graphs. Hence, the equation has only one root. Okay, so the root is actually referring to the intersection point between two graphs. Right? So this is the actual graph. All this will be just the rough work. Right? All this will be rough work. Okay, so now B, verify by calculation that this root lies between 1 and 2. So now I have to rewrite the equation. 4 minus x squared equals to second square half x. Then now I will move the second square to the left hand side. I will let it be fx. Okay, so now to show that the root lies between 1 and 2, I need to count f1 and f2. So it will be 4 minus 1 squared minus second square half. Sorry, it is not second square, it's second half x. Okay, mistake here. This is no square. Alright, so now when you count this value, second half, make sure it is in radians mode. Okay, so otherwise you will get the wrong answer. This is going to be 1.861 greater than 0. So I need 3 significant figures, so I should write 86. Then the other one, 4 minus 2 squared minus second half times 2. Right, this is basically 4 minus 4 minus second 1. Then you will get negative 1.85, which is less than 0. Then you just write here f1 greater than 0 and f2 is less than 0. Hence, there is a sign change. Okay. So when there is a sign change, therefore, the root lies between the two values. Right? So that's the solution of these two questions. That's the solution of this question. Now see, use the iterative formula to determine the root correct to 2 decimal places. Give the answer of each iteration to 4 decimal places. So now xn plus 1 is square root of 4 minus second half xn. So now, just now we have proven that the x lies between 1 and 2. So now your initial guess can be any values in between 1 and 2, or probably you can just take 1 or 2. So I will always take the middle value and let the x naught be 1.5. Okay, then I'm getting x1 as square root of 4 minus second half times 1.5. Remember, calculate all these values using radians mode. So now, iteration for decimal places. Here I will get 1.6227. Okay, when to stop, make sure you get two same decimal place. So now, x2 square root of 4 minus second half of 1.6227. Then this is going to be 1.5961. So when you compare, they are not the same. This is 62, this is 59. Therefore, I have to continue for next step. x3. This is square root of 4 minus second half times 1.5961. Then here is going to be 1.6024. Now again, they are not the same, two decimal place, right? Therefore, continue for the next step, x4. You will be getting 4 minus second half of 1.6024. Then this is going to be 1.6009. So now I'm getting the same two digits as in the previous calculation. Therefore, I will stop my iteration. So my x is going to be 1.60 because we refer to the last calculation. The next digit is 0. Therefore, just ignore the rest and copy 1.60. So that's the solution for this part. Now for question 8, find the quotient and remainder when the cubic function is divided by this divisor. So I will perform the polynomial division. Divisor is 4x squared plus 1. Then the polynomial is 8x cubed plus 4x squared plus 2x plus 7. Now, a term multiplied to 4x squared to get 8x cubed, the term must be 2x. So I will get 8x cubed plus 2x, because 2x times 1. Then after that you minus, so the 4x squared will be brought down. 2x minus 2x is 0, then we bring down the plus 7. Now, to get 4x squared from 4x squared, I need to multiply with plus 1. Therefore, you are getting 4x squared plus 1, because 1 times 1 is 1. Then you minus, so 7 minus 1 is 6. Okay, so from here, the quotient is 2x plus 1, and the remainder is positive 6. That's the solution for question A. Now B, hence means use the previous answer. Find the exact value of this integration. Now exactly the same, right? The polynomial divided by 4x squared plus 1. So now what I need to do is I will copy the question first. Then I will change this to the quotient and remainder. So just now we have found the quotient of 2x plus 1, remainder is 6. So here will be expressed in 2x plus 1. This is a quotient plus remainder over divisor. Okay, so now for the first integration should be no problem, 2x plus 1. But then for the second integration, we need to refer to the formula. Integrate 1 over a squared plus x squared dx equals to 1 over a inverse tangent x over a plus c. Okay, so for you to use this formula, make sure it is 1x squared. And the other term is a squared. So now I will split it into two integrations. Okay, and then at the same time I will factorize the 4 because I need to make it to 1x squared. So here x squared plus 1 over 4 dx and 6. Then limits 0 to half. I split into two integration first. So after that, right, I will change the second form into the same form as this, as the formula. Then I will write, okay, now for your information, this 6 and 4 can be taken out because I want to get 1 in the numerator. So I will write 6 over 4, integrate 1 over x squared plus a squared. So I will write x squared plus, the 1 over 4 is square of half. So it means that now my a is basically half. Okay, then now I can easily use this formula to get the solution. So for integration of 2x plus 1, you have two methods, whether you split it into two terms and integrate term by term, or I will just use integrate ax plus b to the power of n dx, which is ax plus b to the power of n plus 1 over n plus 1. So differentiate ax plus b is a. I'm going to use this formula to calculate or to integrate. So I will get 2x plus 1 degree 2 over the new degree, which is a 2. And now you differentiate 2x plus 1, it will be 2. Now, for the next term, okay, here is going to be 3 over 2. Then I will write plus 3 over 2. So use the formula here. 1 over a, my a is half. So times 1 over half inverse tangent x over half, limits from 0 to half. Okay, so now I will simplify. I will get 2x plus 1 degree 2 over 4 plus, now this 1 over half is 2. 2 times 3 over 2 is basically just 3. So I will get 3 inverse tangent x. Now x over half is basically 2x. Okay, so I will write 2x. Then limits 0 to half. Okay, so now you replace the x by half first. So substitute the half first into the x. So now I will get 2 times half plus 1 squared it over 4 plus 3 inverse tangent 2 times half, then minus when the x is when the x is 0. So 2 times 0 plus 1, then you square it over 4 plus 3 inverse tangent 0. Okay, so here I will get 2 times half is 1. 1 plus 1 is 2. 2 squared, I get 4. Plus 3 inverse tangent, 2 times half is 1. Then minus 2 times 0 is 0. 0 plus 1 is 1. So 1 squared is 1 over 4. After that, inverse tangent 0 is 0. So here plus 0. Then now, here you will be getting 1 plus 3 times inverse tangent 1 is pi over 4. Then minus 1 over 4. So at last, you will be getting 3 over 4 plus 3 over 4 pi. And then from here, I can factorize 3 over 4. And then you will get 1 plus pi. So that's the solution of this question. Now, next question is number 9. The variables x and y satisfy the differential equation. Given y equals to 1, x equals to 1. Solve the differential equation, this is the first part, and find the exact value of y when x equals to 3. This is the second part. giving your answer in the simplified form. Alright, so now I will copy the question. Then now I will split the variables. Since your dx is at the bottom, here is the denominator, so you will move up. So I will move to right side, which means all the x will be moved to right side. So I will get 1 over y dy is 1 over x plus 1 times 3x plus 1 dx. Then now you have to integrate both sides. So for the right hand side, to integrate the rational function, we need to solve the partial fractions. So I will let 1 over x plus 1 times 3x plus 1 be a over x plus 1, then plus b over 3x plus 1. Okay, so for partial fractions, we always get the same denominator as on the left hand side, which means now my first term is a over x plus 1. Now you compare. I have x plus 1. That means I need to times with 3x plus 1 for the first term. So I times 3x plus 1 over 3x plus 1. And then for the second term, b over 3x plus 1, you have the arrow, right? So it means now you need to times with x plus 1. So here I will times x plus 1 over x plus 1. So now we are getting the same denominator in the left and right side. Therefore, I will just refer to numerator. Okay, to find the a and b, I will let the factor be 0. I let this be 0 and let 3x plus 1 be 0. So now I will let x plus 1 be 0 first. Then the x is minus 1. So now I have to substitute x equals to minus 1 in this whole equation. Substitute the x by minus 1. So left hand side is 1. Now I will get a bracket 3 times minus 1 plus 1. That means here 1 equals to negative 2a. Therefore, my a is negative half. Okay, next I will let the 3x plus 1 be 0. That means my x is going to be negative 1 over 3. So left hand side is 1. Right hand side, as long as you see 3x plus 1, the whole bracket is 0. Right, therefore I'm getting the b now. So negative 1 over 3 plus 1 times b. That means from here, I will be getting 2 over 3b equals to 1. Hence, my b is going to be 3 over 2. Once I have found the a and b, I will just substitute back into my general partial fractions. So it will be 1 over x plus 1 times 3x plus 1 equals to a over, okay, look at here, a over x plus 1. But since your a is fraction, I will take out the fraction. I just write 1 over x plus 1. Okay, same as the b. So when you look at here, b over 3x plus 1. Now your b is a fraction, so I will take out the fraction as well. Then it will be plus 3 over 2 times 1 over 3x plus 1. So now I will substitute this result into my integration. So I will rewrite here. It will be integrate 1 over y dy equals to integrate these two terms. So negative half times 1 over x plus 1 plus 3 over 2 times 1 over 3x plus 1 dx. Okay, so now I will split it into two integrations. So it will be negative half integrate x plus 1 dx. Now for your information, since the denominator with degree 1, here is also degree 1, I'm going to use the ln formula to integrate. So the ln formula says integrate f prime x dx, it will be ln fx plus c. Okay, provided the numerator is the differentiation of denominator, which means now here when I differentiate x plus 1, I'm getting 1. Okay, so when you multiply, it will be exactly the same as previous term. Then now same for the denominator here. 3x plus 1 dx. When I differentiate 3x plus 1, I should get 3. So when I compare with the previous term, I have the 3 on top, but then I still have the over 2 in the the 2 in the denominator, which means I have to write half outside. So that 3 times half, it will be 3 over 2 in the previous question, in the previous step. Okay, then for the left hand side, I will just rewrite, because when I differentiate y, I get 1. So now for all of this, I'm going to use ln. It will be ln y, okay, equals to negative half ln of x plus 1 plus half ln of 3x plus 1, then plus c. So you can put modulus for the functions after the ln, or just bracket. So if you are sure that the function will be positive, just put a bracket, no problem. Now, you are given x is 1, y is 1. Now we need to solve the differential equation. So it means that we need to find what is the c. Okay, so when x is 1, y is 1, I'll replace all these values. I will get ln 1 is negative half ln 2, because 1 plus 1 is 2, then plus half ln 4 plus c. So now my c, okay, for your information, ln 1 is 0. So now from here, just move these two terms to the right side. So therefore, my c is going to be half ln 2 minus half ln 4. And then I can simplify this into half. Now, to simplify the ln a minus ln b is ln a over b. Right? So this is going to be ln 2 over 4, which is half ln half. But then we have another formula. Ln a power b is b ln a. Alright? So you can say this is basically half ln 2 power negative 1. Then I will write this is negative half ln 2. So that is my c. Now I will continue here. So substitute this c. I will get ln y equals to negative half ln 1 x plus 1, and then plus half ln 3x plus 1, then plus c is negative half ln 2. So now the question says solve. Okay, so basically I will say that this is my ln, right? Or this is my solution, or if you want, you can just further simplify, because from here you have so many ln, I can factorize. But before I simplify the ln, use the formula a ln b is ln a b power a. That means this is ln x plus 1 power negative half, okay, plus ln 3x plus 1 power half, then minus ln 2 power half. So now I can combine all. So as long as you have ln a plus ln b, I can combine them into one ln. That will be ln a times b. And then ln a minus ln b is going to be ln a over b. So the plus I will times, and the minus I will divide. So ln, okay. Now for the first one, I can just remain the minus, no problem. So that means I will get 3x plus half plus 1 power half over, okay, because these two are minus, so it will be multiplication, but they will be at the bottom. So it will be x plus 1 degree half and 2 power half. Then this is going to be my ln y. So now since you have one ln on both sides, so my y is going to be square root of all of this, right? Because degree half. So 3x plus 1 over 2 times x plus 1. Because this means ln of 3x plus 1 over, when you have same base, same degree, you can just take out the half, right? It will be 2 times x plus 1. Then here is degree half, and this is degree half. That's why the half can be taken out. So here is ln 3x plus 1 over 2 bracket x plus 1 degree half. This is how I get it. So we have solved the differential equation, and now the second part is find the exact value of y when x equals to 3. Okay, So when x equals to 3, the y is square root of 3 times 3 plus 1 over 2 times 3 plus 1. So that means this is going to be 10 over 8, right? So then you can simplify this into square root of 5 over 4. So now for the over 4, you can further simplify. This is square root 5 over square root 4, which means you are getting square root 5 over 2. So that's the value of the y when x equals to 3. Okay, now for question number 10. The points A and B have position vectors 2i plus j plus k and I minus 2j plus k plus 2k respectively, which means now OA is 2, 1, 1, OB is 1 minus 2, 2. Now the line L has this vector equation. Find a vector equation for the line through A and B. So now I need to find vector AB. So vector AB is OB minus OA. That means you'll be getting 1, negative 2, 2 minus 2, 1, 1. Then here is going to be negative 1, negative 3, and 1. So you can leave this in this form, or probably you can just factorize a minus for the direction vector. So now the vector equation of the line through A and B is going to be R equals to, you can pick any point. You can use OA or OB, up to you. So I will write OA plus TAB. Then here is going to be, my OA will be 2, 1, 1 plus T of minus 1, minus 3, 1. So now in the vector AB, since there are two minus sign and one positive sign, I can factorize a minus, right? If you don't want, you can just leave it in that form. So when I factorize minus, my t becomes minus t. So I change the minus t to s. Then I will get the vector of 1, 3, minus 1. So you can leave your answer in any forms, first or second form, is up to you. Now B, find the acute angle between the directions AB and L, giving your answers in degree. Let's say this is the L, this is the line with AB. Unifying angle here, acute angle. So for the line L, we have the B1. For the line 2, the AB, the line passes through AB, we have the B2. Okay, so now from the line here, right, I have to let this be B1. So R equals to minus 1, 2, minus 3. Okay, this is a given line. 1, 2, minus 3 plus mu, then 1 minus 3 minus 2. So 1 minus 3 minus 2. So I let the B1. So now my B1 is 1, negative 2, negative 3, negative 2. So for the line RB, okay, RAB, then I have found previously 2, 1, 1. So here 2, 1, 1 plus S 1, 3 minus 1. You may use the original vector AB, right? So from here, I will get my B2 is 1, 3 minus 1. So now, I let theta be the angle between two lines. So use the scalar products formula. B1 dot B2 is magnitude B1, magnitude B2 cos theta. Therefore, 1 minus 3 minus 2 dot 1, 3 minus 1 equals to square root of 1 square plus negative 3 square plus negative 2 squared. Then square root of 1 square plus 3 square plus minus 1 squared cos theta. Okay, so for the scalar product formula, you just times and plus. So here I will get 1 times 1 plus negative 3 times 3 plus negative 2 times minus 1 equals to the first one will square all. Okay, it will be 14. And then the second one, it will be 11. Then cos theta. So for the left hand side, 1 minus 9 plus 2, you will get minus 6. Then now, I will be getting my cos theta as negative 6 over square root 14 times square root 11. So your theta here is going to be 118.9 when you just press inverse cos. But then when you refer to the question, it's mentioned acute. Means that I have found here. Right? Now to get the acute angle, it will be 180 minus the angle that I have just found. So here, acute angle is 180 minus 118.9. Therefore, you'll be getting 61.1. Okay, I get this obtuse angle because I have factorized the minus. Here, I have factorized the minus from the original vector, direction vector. If you are using this in the calculation, you will direct get the answer. Okay, so it's not wrong, but here is the method. Here is the working if I factorize a minus from the direction vector. Okay, now see, show that the line through A and B does not intersect with the given line. So now I will write R equals to RAB. So my first R is, when you look at the question here, okay, so from here I will write 1 plus mu, alright, 2 minus 3 mu, then minus 3 minus 2 mu. I open the brackets. So here I will write 1 plus mu, 2 minus 3 mu for the second component, minus 3 minus 2 mu. That equals to RAB. I'm using the simplified form. You may use the first form, up to you. I'm using the simplified form. It will be 2 plus 1s, 1 plus 3s, and 1 plus minus s. Okay, when you do expansion. So here I will get 2 plus s, 1 plus 3s, 1 minus s. So I let this be 3 equations. Now you want to show that they are not intersecting, means now you have to choose any 2 equations to find the unknowns. After that, you substitute both unknowns into the remaining equations for checking. See whether the left hand side is same as right hand side. So now, since we need to solve, then I will use the first and third equation because you have plus s and minus s. So I will plus these 2 equations together. So 1 plus minus 3 is minus 2. Mu plus minus 2 mu is negative 1 mu. Then right hand side 2 plus 1, it will be 3. The s plus minus s will be 0. Then from here, the mu move to right side, the 3 move to the other side. So you will get minus 2 minus 3 is mu, and at last your mu is minus 5. So I get this mu value from first and second equation. That means now you have to find the s from first or second equation. So now I substitute into first equation to get the s. So 1 plus the mu is minus 5 equals to 2 plus s, which means 1 plus minus 5 is minus 4, is 2 plus s. Therefore, my s is going to be minus 6 when you move the 2 to the left hand side. After you found these 2 unknowns, substitute into the remaining equation. So I will substitute into second equation for checking. So my left hand side on the second equation will be 2 minus 3 mu. Now I replace the mu value by minus 5. So you will get 17. Okay, then the right hand side is going to be 1 plus 3s. So it will be 1 plus 3 times minus 6. So here 3 times minus 6 is minus 18. Minus 18 plus 1 minus 17. So obviously they are not the same. So left hand side is different from right hand side. Therefore, both lines are not intersecting. Okay. Now, question 11. The diagram shows a curve y equals to sine x cos 2x for x between 0 and half pi and the maximum points m. Find the x coordinates of m, giving your answer correct to 3 significant figures. Means that you need to find maximum point. So now maximum points is found using differentiation. So now I have to use d over dx uv, the product rule. because it is product of two functions. It will be uv prime plus vu prime. Okay, so now I will let my sine x be the u. So now my u is sine x, my u prime is cos x, then my v prime, v, uv, okay? I better write like in this order. This is u prime is cos x, v is cos 2x, v prime differential cos is minus sine, rewrite the 2x, differential 2x is 2. So now the product rule is basically cross multiplication, so this is minus. So I will get dy dx equals to sine x times minus 2 sine 2x plus cos x times cos 2x. Okay, and then now I need to solve this. So I have the double angle formula here. This is 2x, 2x. So I will change it to normal function. That means sine 2x, right? Use the double angle formula. Sine 2a is 2 sine a cos a. And then here is the cos, and here is cos. This is sine. Therefore, I will change. So cos 2a, I will change to 2 cos square a minus 1. Okay, these are the two double angle formulas that I'm going to apply. So here will be sine. This is sine x. So here minus 2. Sine 2x is going to be 2 sine x cos x. Then cos x. The cos 2x is going to be 2 cos square x minus 1. Okay. Then here will be minus 4. And then sine x is sine square x. Then multiply with cos x. Then here when you do expansion, it will be 2 cos cube x. Or no need to do expansion because I can factorize. Okay, I have the common term, sine cos x. So here I will write cos x. I will rewrite. Then this is going to be 2 cos square x minus 1. Now the common term, okay, here cos sine is sine squared. So the common term is the cos. So I will factorize the cos x. Then I will get minus 4. The sine square x will be changed to 1 minus cos square x using the identity. Sine square x plus cos square x is 1. Okay, so sine square x is 1 minus cos square x. And then here is going to be plus 2 cos square x minus 1. So then I will get cos x multiply with, here do expansion, 4 plus 4 cos square x plus 2 cos square x minus 1. Okay, and now my simplest form of the dy dx is going to be 6 cos square x. Right, here minus 4 times 1 is minus. So here is going to be minus 5. Okay, then now I will say at m, dy dx equals to 0. That means 0 is cos x multiplied with 6 cos square x minus 5. Then now my cos x equals to 0 or 6 cos square x minus 5 equals to 0. So when look at the graph here, at m, your x will not be 0. Okay, and now you consider the x from 0 to half pi. So when you refer to the cos graph, it is 0 at pi over 2 and 3 pi over 2. So the x will be pi over 2 or 3 pi over 2, but obviously it will not be half pi because half pi is here. Okay, that means both cannot be accepted. So omitted. Now I have to get the answer from the second equation, which means cos square x is 5 over 6. So the cos x is plus minus square root 5 over 6. Then now, since your x is between 0 and half pi, so definitely it is in the first quadrant, then your cos x should be positive 5 over 6, cannot be negative. Then now, when you take inverse cos square root 5 over 6, you will get 0.421. Okay, therefore, when you look at the question just says x coordinates and equal to 3 significant figures. Therefore, I have found the answer. Okay. Now B. Using the substitution u is cos x, find the area of the shaded region enclosed by the curve, the x-axis in the first quadrant, giving your answer in the simplest exact form. So now look at the graph here. We need to integrate from this 0 until this point. So now firstly I have to find what is this point. This point is when y equals to 0. Okay. Then later we will do integration. So your y is sine x cos 2x. Now when y equals to 0, 0 is sine x cos 2x, which means either sine x equals to 0 or cos 2x equals to 0. So when sine x equals to 0, refer to the sine graph. It will be 0, pi, or 2 pi. Okay, but we know that this point shouldn't be 0. Okay, but it is greater than 0 and less than half pi, which means now we cannot accept all this solution. Okay, because the x is between 0 and half pi. Now, cos 2x equals to 0. So for the cos graph, this is sine. So for cos graph, right, I will get cos 2x equals to 0. Okay, so here, when you refer to this graph, it will be 2 pi, it will be pi, when 0 means that it is at pi over 2 and 3 pi over 2. Okay, but then when you solve this, cos 2x equals to 0, and the x is from 0 to half pi. That means now my 2x will accept the values from 0 to pi. So now I will get 2x will be half pi based on this, right? Therefore, my x will be just pi over 4. So I know that in my graph, here is going to be pi over 4. So now I have to integrate the graph from 0 to pi over 4 in order to get the area of the shaded region. So now my area of the shaded region is to integrate 0 to half 1 over 4 pi sine x cos 2x dx. And then you are given the hint. Use u is cos 1x. So I don't have cos 1x here. That means I have to change my cos 2x to 2 cos square x minus 1. This is the double angle formula. Okay. And then now I will let u be cos x. Then now your du over dx is negative sine x. Therefore, sine x dx will be negative du. Okay, after this, we have to get the new limits. So when x equals to 0, your u is cos 0, which is 1. When x equals to pi over 4, the u is cos pi over 4, which is 1 over square root 2. So now with this, I will change all to u. So x from 0, I change to 1. X equals to pi over 4 will be changed to 1 over square root 2. Now, this sine x dx will be combined to be minus du. So I will write minus outside and then du. 2 cos square x minus 1, it will be 2u squared minus 1. Because my u is a cos x. So now when I integrate this, I will write the minus outside. 2u squared becomes 2u cubed over 3. The minus 1 becomes minus u. Limits from 1 to 1 over square root 2. And now I will replace accordingly. It will be negative of 2 over 3, 1 over square root 2 power 3 minus 1 over square root 2 minus 2 over 3 times 1 cube minus 1. So it will be negative of 2 over 3. This is 1 over 2 root 2 minus 1 over square root 2 negative 2 over 3 minus 1. Then at last it will be, okay, so when you simplify, it will be negative of 1 over 3 root 2 minus 1 over square root 2 minus 2 over 3 minus 1 is negative 1 over 3. So here you will get, okay, let me check the working first. So here you will get, okay, let me check. Right. Okay, so here you will get negative. Now, this is 1 over 3 minus, you see, this is 1 over 3 minus 1. Okay, if you ignore this, that means I'm getting negative 2 over 3. So, negative 2 over 3 square root 2. Okay, then here minus minus is a plus, 1 over 3. So, here is going to be 2 over 3 square root 3 plus 1 over 3. So, the 2 over 3 square root 2, sorry. So 2 over square root 2 is going to be square root 2 over 3. Okay, because we know that the 2 is square root 2 times square root 2. So I will get square root 2 times square root 2 over 3 square root 2. Then plus 1 over 3. So now the square root 2 will be cancelled off. Alright, then I will be getting square root 2 over 3. Plus 1 over 3. Then now, the 1 over 3 can be taken out. Then you get square root 2 plus 1. Sorry, I made a mistake. Okay, this negative, I forgot to times in to the second term. It should be minus. Alright, so this is the area of the shaded region. Okay, so we have come to the end of the video. Thanks for watching. If you enjoy watching my video, please subscribe to my channel and stay tuned for more upcoming videos. Thank you. Bye.